Okay, here we go. This is Rational Wiki trying to tell us about the flat earth movement. They have some questions in this article that purports to debunk the flat earth. Basically, they're just making fun of it without actually thinking. It's kind of hilarious. But here we go. We got a bunch of questions that are answered by the Flat Earth Society, which is a shill organization, basically a gatekeeper. It's a bunch of retarded answers. I mean, ridiculous answers. Okay, question one. Why do you guys believe the earth is flat? Well, because you can see too far, and every direction you look, it's flat. 99% of surveyors are treating it as a flat plane. The only time it doesn't go flat is when you try to go very long distances. Yeah, they say it looks that way up close. Yeah, whatever. Yeah, it does. Every measurement that you can take is consistent with it's flat. And they'll explain, well, you can see too far because light is refracting. Okay, that's convenient. Yeah, no, you can see a certain distance, and then you can't. That's all there is to it. All right, two. What's underneath the Earth? Well, we don't know. We're told we've only dug 8 miles down, and then we ran into some mud that was boiling with hydrogen. And then they quit because their drill bits were melting, and so on. But we don't know. We can only go a certain distance up, certain distance down. Apparently, it's 8 miles down. Number three. Why aren't people falling off the edge of the Earth? Uh, well, we there is no edge as far as we know. You go south away from the center point at the North Pole, right under Polaris, and eventually it gets colder and colder and windier, and officially we're not allowed to go past 60 degrees south without government escort. The Antarctic Treaty has made sure that no one's allowed to go down there and just wander around. You gotta have an escort, and you're not allowed to go during certain seasons or certain hours. It's ridiculous. Like, yeah, no flights go over the South Pole, and we're not allowed to go down there. And it's a 3 mile high ice wall. Alright, next, if the Earth is flat, how can you travel all the way around the Earth in one direction and return to the same place? Well, that's pretty simple. If it's flat and your compass is always pointing north, as you go in one direction, if you keep your compass pointed toward the center of the pizza or the disc, you're going to make a giant curve. It works the same way on the ball on the flat plane. Follow-up question, why are ships and airplanes not constantly required to turn left or right to make this circle? Well, they are. This is a pretty ridiculous question. If a plane wants to go directly east or west on one of the lines of latitude, keeping the same distance from the center point or the North Pole, they would need to constantly adjust their heading so that the compass is always pointing toward the center. It's pretty basic. Second question, how do ships and airplanes achieve fantastic velocities needed to fly from Australia to South America in the observed travel time? Well, the distance between Australia and South America is measured in nautical miles, and a nautical mile is based on the angles observed to the stars and converted into a map. They are not based on physical measurements of the terrain below. So a plane traveling from Australia to South America would travel a certain number of degrees of longitude, and those degrees of longitude are considered to be or translated into a certain number of actual miles on the terrain, but the measurement is done in degrees, and those degrees are generated by the stars. Now we don't know where the stars are, but all the maps are based on those stars. So it's ridiculous to think, well, we know that distances in the south are the same as they are in the north because the plane is flying a certain number of miles. No, they're flying a number of degrees, also known as nautical miles, and then those nautical miles have a standard conversion rate, which was only recently agreed upon. And if you'll notice, if you go look at a flight tracker, you'll notice that it's rare to see planes flying only in the southern hemisphere. They also most often will fly into the north and then back to the south. And if you do get a flight that's only in the southern hemisphere, it takes a long time, and the plane is flying generally slower than it is rated to fly. And the reason for that is that they're measuring in degrees or nautical miles, and they're probably pushing the plane to a reasonable limit near its maximum ability, which is generally about 600 miles an hour. But if you go look, they're flying at about 470 miles an hour all the time, routinely. If you're finding a flight in the southern hemisphere, it's going to be going way slower than the plane is rated for. You'll never find a plane flying at its rated capacity in the southern hemisphere. And the reason for that is that it's measuring in how many degrees it is moving and converting into actual mileage. And if you do that conversion and you're going farther than you think, you're going to get a slower speed than you should get. There are also other complications, like the jet stream is much faster and more violent as you get closer to the south, to the ice wall rim. Faster and faster. They go up to 300 knots, which would put a plane. It's about 350 miles an hour. Make a plane go about 1,000 miles an hour over the ground. So there are a lot of complications down there, and it's curious that planes fly way too slow compared to their rated capacity. The only plane that is allowed to fly between South America and Australia is a 4-engine plane. It's like one of the biggest planes they make. And it can go about 600 miles an hour relative to the air that it flies through, and generally they will list it at about 470, 475, something like that. And it's curious. Doesn't matter which direction they're going with the jet stream or without it. They're always flying way too slow, which can either mean for some reason pilots fly slow in the southern hemisphere for no reason, or they're actually covering a lot of distance, and it just takes a lot longer to make a 1 degree change when you're down there. And when you do the conversion, it shows up as, oh, the plane's going way too slow. But it looks like it makes more sense that they're just covering a lot of ground and they're measuring it in degrees. And when you do the conversion, it comes out to be too slow. But they're actually doing a big loop, and that would explain why the flights are so rare and most of them go to the center before they come back down. It's because the distance is taking a lot more fuel, and they figured that out, and they don't like to do those flights. So they're expensive and they're long and they're very rare. There's like one plane that goes between Australia and South America every day. And in North America, there are just a swarm of planes going everywhere. So, yeah, take a closer look at that one. Alright, if the Earth is flat, what about the sun, moon, and the stars in the sky, or the sky itself? What kind of question is that? What about them? There are lights in the sky. And then they give this bullshit, like, answer about they're in a dome, or celestial objects, just projections on the dome, or 6,000 miles away. Now, generally, flat earthers are like, well, they're probably about 3,000 miles away, but truth is, if a laser is being shot at you in space, you don't know how far away that laser is. If you're in a dark room and there's a laser pointing at you, you don't know how far it is. You have no reference point. And since we can't go up there to look, you just have no idea. So, yeah, moving right along. How are time zones possible on a flat Earth? Okay, shouldn't the sun be visible from every part of the world at all times? No. If you go far enough away from something, it's going to fade out and refract into the ground. It's like a light. Imagine you're in the ocean, and we're basically in the ocean, in an ocean of atmosphere. So imagine you're actually underwater, and there's a light shining down on the water. As it moves away from you, eventually you're not going to be able to see that light anymore. Eventually, the water or the atmosphere is going to refract all the light away from you. It's going to be dark again until the sun comes back around. It's the same concept. Alright, next. Doesn't our current understanding of gravity make a disc-shaped model of the Earth impossible? Gravity is just buoyancy and density. There is a force that makes dense, heavy things go down, and that's all we know. It's similar to when you ask a scientist what is magnetism, what is electricity, they'll say, well, don't ask me that, but basically there are just certain forces that we know exist and we don't know what they are. They just are. There's a great Feynman video about that, where somebody asks him what's electricity or what's magnetism, and he gets flustered and says, well, they're just certain things that just are. And we give them names, basically. So they gave this concept of dense, heavy things going down and light, floaty things going up a name. They called it gravity, and then they said, well, all those lights in the sky, those are all big balls of rock, and what holds this whole light system, all those lights near us, is this same mysterious thing called gravity. It's like magic. It holds the moon next to us, and we got all this mathematical crap that explains the whole system, but when we look really far out, well, then it doesn't work anymore, and then we have to invent dark matter and dark energy and all this baloney. But yeah, in the end of it, it's pretty simple. Dense, heavy things go down, light, buoyant things go up. That's about it.